Hello, I'm Dr. Millicent Thomas. In this video, I would like to explain how to draw a scatter plot for a bivariate data. When we have two variables, say x and y variable, and if you would like to get a graphical representation for that, a scatter plot is a very good graph to represent a bivariate data. We can also interpret the scatter plots and add categorical variables to scatter plots. The scatter plots are always used to display quantitative bivariate data, that is x and y. One variable makes up the x-axis, the other variable is represented by the vertical line, which is the y-axis. The one on the x-axis is always the explanatory variable, and the value on the y-axis is your dependent variable. So the dependent variable or the response variable is y. The explanatory variable or the independent variable is x. X is always the horizontal axis and y is the vertical axis. Let's see this example. This talks about the ice cream sales with the noon temperature. If this is taken as the independent variable, and if this is your dependent variable, the response variable, then we can plot these data in a graph like this. So we take the x-axis, which represents the explanatory variable, and the y-axis is the response variable. So the x-axis is the temperature and y-axis is the sales. We can plot the points. The points are all scattered all over. So this is a scatter plot for the data what we have about the ice cream sales. When we see a scatter plot, we can look for the form of the curve, the direction, the strength, and we can look for an outlier. So the diagram, the scatter plot, will explain the form of it, the direction in which it goes, how closely the points are to find the strength, and to find the relationship we can check whether there is an outlier or not. Now in my first diagram, you have all these points drawn as if it is lying on a line, though those points do not lie exactly on a line, but these points are almost close to a line which I can imagine. So that is approximately linear, and we call that as a linear relationship. Whereas in the second diagram, I don't have a straight line representation. Maybe I can imagine a curve. So there is a curvilinear path attached to this. So it does not have a linear relationship. In this case, the points are scattered all over, and I cannot find a linear relationship or a curvilinear relationship. So I can say there is no relationship, or it has a very weak relationship. When we talk about the direction, we can see whether it has a positive slope or a negative slope. If it has a positive slope, it is positively associated. If it has a negative slope, then it is negatively associated. In order to find the strength of the relationship between the two variables, the x variable and the y variable, or the dependent variable and the independent variable, or the explanatory variable and the response variable, we always see the scatter plot and see how it is scattered. I can imagine a line representing all this data, and the points are almost close to this line, and it has a negative slope. So, and since these points are very close to the line, I can say it has a strong negative relationship. The second diagram also, I can imagine a line representing this data, but the points are not closely associated with this line. They are all spread away from the line, and hence it has a weaker negative relationship. We can also talk about the outlier. See, I can imagine a line representing this data, but point over here is further away from these group, the rest of the data here. So in this case, I call this may be an outlier. This is a value which is unusual. It is outside of the overall pattern of the relationship. So you call that as an outlier. Now with the help of these scatter plots, we can find a line of best fit, and usually that line is called the trend line for the scatter plot, and that line is also known as the least square regression line, and we will discuss about this in our next chapter, the least square regression line. But the least square regression lines are drawn for a scatter plot, and that helps us to predict the future values. For example, in this screen, we have got values plotted, the temperature and the sales. But if you do not have a data for 21 degrees, you can approximate the sales during that for that temperature. So if you take this as the trend line, the line which is drawn as the trend line, then the approximate value 480 can be obtained for a value in between the given data. So it is called an interpolation. The same way, if we are trying to find a value outside the given result, remember those values were given only from 10 to 26, but we are interested in finding the value for 29 degree. So that can also be approximated. You can get an approximate value using this regression line 740. And since it is outside of the set of data, it is your extrapolation. So the scatter plot along with the regression lines are very, very helpful to find the interpolation and extrapolation for the set of data given in a question. So in this video, we discussed clearly about a scatter plot. And in my next video, I will show you how to draw the scatter plot using our graphing calculator. Hope this video was helpful. Thank you for watching.